Welcome to qnawire.
All right, today we're doing chapter 16, section problem 102 from Chemistry, the Essential Science, edition 14 by Brown. The question's asking us to tell if the following statements are true, and before we can be able to do that, we first have to be able to tell if the difference between the KB and KA, and KB is the concentration of base at equilibrium, and Ka is the concentration of acid at equilibrium. And whenever we're trying to find the pKb or the pKa, it's just the negative log. The lowercase p is just an abbreviation for negative log, and we'll see that a lot whenever we are in this chapter. And it is just universal, especially in chemistry, as a shorthand notation. Also, we can find the concentration of Kb by doing 10 to the negative p Kb. And we'll be using that for question C and D in this question as well. So to be able to answer the following questions, we also need to know the pH scale and the pOH scale. So when we're looking at the Kb and Ka, the Ka is dealing with the pH scale, where the Kb is dealing with the pOH scale. And so the pH scale is a very widely known scale. It goes 0 to 14, where 14 is your base and 0 is your acid. In the middle, 7 is your neutral, usually known as for the water area, where your pOH is the opposite. And so when we're looking at this question, we're going to be looking at this and looking at the two different scales and trying to be able to figure out this question. So for question A, it asks is the stronger the base, the smaller the pKb. So we're asking for the pKb. So we have to look at the pOH square. So we want it to be a strong base. So for it to be a strong base, we have to be up here at the strong base side. So therefore, we want it to be a very small number. So the first statement will be true. So A is true. The smaller the pKa, the stronger the base. Sorry, the smaller the pKb. All right, so for question B, it's the opposite, the question's asking. The stronger the base, the larger the pKb. So if the pKb gets larger, it's going into the acidity territory. It's going into 7 to 8 of the pOH scale. And so therefore, that statement would be false. All right, question C is asking the stronger the base, the smaller the Kb. And so for C, we're going to be using the equation that I wrote a little bit earlier, where the Kb is equal to the negative 10 of the pKb. So they're saying the smaller the Kb. So if our pKa was 2, so if we want a strong base, therefore our strong base would be somewhere on the lower end of our pH scale. Therefore, let's say 2, it's going to be a very small number. But if we would have a Kb and we would have a weak base, so somewhere closer to the 14 range, so let's just say 10, it'll be a very small number. So if we have a strong base, it'll be a larger number, where if it would be a weak base, it would be a smaller number. So C is false. And in that question, we also answered D. And so therefore, the stronger the base, the larger the pKb. And that answer is true. Because the stronger the base, the larger the pKb is. And we answered that with this equation right here. Because the base is stronger, therefore the pKb is smaller, so it's around 2, and so therefore it's only 0.01 instead of 0.000001. So question part E is asking, the stronger the base, the smaller the pKa. So once again, we're looking up here. So if we were looking at the pOH, we would be looking around like 2, 3. And so therefore the pH would be the opposite. So it would be around 12. So therefore the pKa would therefore be very large. And so therefore E would be false. So the stronger the base, the smaller the pKa of the conjugate base acid. And so therefore this is false. And then F, it says the stronger the base, the larger the pKa of its conjugate acid. And this is true from the same answer that we just gave above. Thank you for listening.